Welcome to another physics class. In our last lesson, we started the topic uses of dimension, and we work on number 1 uses and number 2. Now we are on number 3. Number 3. And number 3 is to derive the exact physical relation or formula between physical quantities. That is, how two or more physical quantities can be joined together to form formula in physics. We use dimension to derive that. Now, example under this one. Example. Now, this is the first example. The period T of oscillation of simple pendulum is a function of mass n, length l, and acceleration due to gravity g. Use dimension analysis to derive the physical relation between T, M, L, and G. Now, solution to this one. Don't forget, if you want to know more on this thing, as I said, try to like, share, and subscribe to the channel so that when I have a new update or video like this, you'll be able to see the notification. Because what we are going to look at today is the continuation of what we have done in the previous lesson. So let's continue. So you can now say the quantity present are 1, 2, 3, 4 quantities. That is period, mass, length, and acceleration due to gravity. And according to the question says T is a function of all others. So we can now say T is directly proportional to M, L, and G. T is directly proportional to M, L, and G. Now from this one, you can now say T is equal to K, M, L, and G. Now, mind you, we don't know how they were related together. So you now say let T is equal to K into M raised to power S, L raised to power Y, G raised to power Z. If that is the case, we now want to look at find the value of S, Y, and Z. Once you know the value of S, Y, and Z, using dimension analysis, we're able to write the correct formula between the 4 quantities. Now, from there now, we can now say that T, let's assume K is a constant. K is a constant. And let's say is equal to 1. So we are going to have T is equal to M raised to power S, L raised to power Y, G raised to power Z. Now, to write the dimension now, dimension of each quantity now. From the question, the period T is written as capital letter. It means the dimension of period. Mass, as I told you in last lesson, the dimension for mass is capital M. For length is capital L. For acceleration due to gravity, don't forget we done that of linear acceleration in our previous lesson. Then the acceleration due to gravity and linear acceleration, we have the same dimension. So G also will be equal to LT raised to power minus 2. Don't forget we done that during the last lesson. That is under the derived quantities and their dimension. So now, put in all this one, we are going to have M raised to power S, L raised to power Y, and for G, L, T raised to power minus 2 into bracket Z. Let's open this bracket. So we are going to have T is equal to M raised to power S, L raised to power Y, L raised to power Z, T raised to power minus 2Z. Now, if that is the case, let's apply law of indices here. So we are going to have T is equal to M raised to power S, L raised to power Y plus Z, because this is L, and T raised to power minus 2Z. Now, we can now say that now, in the right-hand side, we have three quantities. That is mass, length, and period. But here, in the right-hand side, we have just one quantity, which is period. What we are going to do now is we must balance the equation by saying the left-hand side must be equal to right-hand side. That is what we have in the right-hand side. The number of quantity we have there must be in the left-hand side. And if you look at it now, T is here, but we don't have M and L. So let's introduce M and L in the left-hand side. That's M raised to power is 0, L raised to power is 0, then the T that's already there, T raised to power 1. Then it will be equal to M raised to power S, Y raised to power Y plus Z, then T raised to power minus 2Z. Now, we've balanced the equation now, but mark you or note that anything raised to power 0 in indices is what? 1. Therefore, this one will be 1, this one will be 1, and 1 multiplied by T will still give our T. That is why we've written the equation like that. So, let's now compare the two sides. That's what we call indices equation under indices. Let's compare the two sides. So we are going to have M raised to power S is equal to M raised to power 0. Again, you can now see that this is indices equation. So this one will now give us S raised to power 0. Let's take L also. Let's take L. This one should be L. Let's take L now. That will be L raised to power Y plus Z equal to L raised to power 0. Then we are going to have the same base, different power. Y plus Z is equal to 0. The next thing is T. That will be T raised to power minus 2Z equal to T raised to power 1. Then this one will now give us minus 2Z is equal to 1. Now, if you look at it now, we have three equations on the board. Call this one equation 1, call this one equation 2, and call this one equation 3. Now, from equation 1, we don't need to worry ourselves. S is already 0. We can now use what we have in equation 2 and 3 to find the value of y and z. Now we can now say from equation 3 now, from equation 3, that is minus 2z is equal to 1. If that is the case, then z will be equal to 1 over 2. Now, we got z as half from this one. Now, let's now substitute half for this one. Now say substitute half for z in equation 2. In equation 2. Then our equation 2 is y plus z is equal to 0. And z is half. So you have y plus half is equal to 0. Therefore, y now be equal to minus half. Now, from what I've done now, we can now say that s is equal to 0, y is equal to minus half, and z is equal to half. Now go back to what we have been doing. Come back here. You now say from t is equal to m raised to power x, l raised to power y, and g raised to power z. We've got the value of s, y, and z now. Now, note something around this place. When I wanted to write the dimension, according to what I told you in our previous lesson, that everything letter must change to what? Capital letter. That's what we've observed here now. Here is small letter because we are not ready to write the dimension. Now, we return back to the original equation now because we want to get the relationship between t, m, and l now. So we can now say that t is equal to m raised to by 0 since s is equal to 0. L raised to power, since y is equal to minus half, and g raised to power half, since our z is half. Now, from mathematics indices, anything raised to power 0 is 1. So m will go away. Then we are now left with t is equal to l raised to power minus half, g raised to power half. Here, apply law of indices here also. Then it will give us 1 over square root of L, 1 over square root of L multiplied by square root of G. Then from there, we are going to have our T now will be equal to from this point, square root of G over square root of L. And finally, the physical relation between the quantity is t is equal to square root of G over L. That's the final state. T is equal to square root of G over L. And from this formula now, we can now say that the period of oscillation of the simple pendulum does not depend on mass, because mass is absent here. So it only depends on acceleration due to gravity G and length of the pendulum. This is the question for example 2. The speed v of wave in a wire of Young modulus E and density P is given as V is directly proportional to EP. Use dimension analysis to show the relation between VE and P. Now, we want to find the relation between these three quantities. Use the same method. Solution. V, according to the question, is directly proportional to Young modulus and density. But this is not the formula between them. We want to derive the formula between them now. So you can now say V is equal to K into bracket EP. Now, use the same method. Now say let V is equal to K into e raised to power. Let's use another alphabet now. A and density raised to power B. Now to find the relationship now, that is why we introduce the A and B. So we want to know the value of A and B. Once you know the value of A and B now, we'll be able to find the relationship between the three quantities. Now, don't forget, but the question says V is speed. And as I told you the other time will not permit us again now to go back to dimension and solve out the dimension of speed, solve out the dimension of Young modulus and that of density. But once we have learned it right from previous lesson, we are just going to copy the dimension of each quantity in now. For speed or velocity, dimension now. Dimension. For V, according to what we've learned, is Lt raised to power minus 1. For Young modulus, that is N L raised to power minus 1, T raised to power minus 2. For density, that will be N into L raised to power minus 3. That's what I told you the other time. If we are new to this lesson now, then this one may give you problem. That where we get all this one, please try to like, share and subscribe so that you get the notification of other lesson or other previous lessons. So you're able to look at it and study it and comprehend what we are doing here now. So these are the dimensions of speed, Young modulus and density. Let's put it in here now. So then we are going to have for speed, T raised to power minus 1 is equal to K into M L raised to power minus 1, T raised to power minus 2. Don't forget, the power on this one is A. Then M L raised to power minus 3. And the power of this one is B. Close the bracket again now. Now, we now say, let K is a constant. K is a constant. Let's say it's equal to 1. Now, we are going to have L T raised to power minus 1 will be equal to, open the bracket now. That's M raised to power A, L raised to power, that's minus A, because minus 1 multiplied by A is minus A. Then T raised to power minus 2A. We've opened that one now. Let's open this one too. That will be M raised to power b and L raised to power minus 3b. We've opened all the bracket now. The next thing is to collect the like time here. Then we are going to have L t raised to power minus 1 will be equal to mn. That's m into a plus b mn, law of indices. Then also L into a raised to power minus c, then minus 3b ln, law of indices. Don't forget. Then what else? T raised to power minus 2a. Now, we reduce this one now to just 3 terms. Then the next thing to see, left hand side must be equal to right hand side. And if that is the case, here now we have L and T. Here we have MLT. It means what is left out here is M. So we need to introduce that M. So we are going to have L raised to power 0, L raised to power 1, T raised to power minus 1. So from there it will be equal to M A plus B raised to power A plus B L raised minus A minus 3B, then T raised to power minus 2A. Don't forget, anything raised to power 0 is what? 1. So we still retain our LT here, but just to comply with the rule. So from here now, this is another area we need to apply indices equation now. Compare this one with this one. We are going to have M A raised to A plus B is equal to n raised to power 0. Then this one will now give us A plus B equal to 0. The same base, different power. Law of indices. Take L also. That will be L raised to power A minus 3B. Then compare with this one, it will be equal to L raised to power 1. So we are going to have, this one will now give us minus A minus 3B is equal to 1. Then the last one, T here, T raised to power minus 2A will be equal to T raised to power minus 1. Then this one also will give us, it will give us minus 2A is equal to minus 1. Now, another 3 equations, call this one equation 1, call this one equation 2, call this one equation 3. And within the 3 equations, we have just 2 variables, which are A and B. Let's look for A and B now. We can now see from equation 3 now, which is minus 2A is equal to minus 1. Then here now, minus, it will equal to A now will be equal to what? Minus over 2. So our A now will be equal to half. Once we got half for A, then we can now use either equation 1 or equation 2 to get our B. Let's use equation 1. So let's use equation 1. So from, we now say substitute half for A in equation 1. And what is equation 1? A plus B equals 0. So from there now you can now say our A is half. Half now plus B equal 0. B now be equal to minus half. B is equal to minus half. So from there now, we can now say that our A is minus half, B is, our A is half, B is minus half. Now say from V is equal to K into E raised to power A and P raised to power B. Already we said K is equal to is a constant. So we have P now is equal to E raised to power A, B raised to power, P raised to power B. And the value of A and B as we know, let's write the value now. Then we are going to have V now is equal to Young modulo raised to power half density raised to power minus half. Apply law of indices. V now is equal to square root of E multiplied by 1 over square root of density. So finally, the relation will now be equal to V is equal to square root of E over P. That will be the final answer. That is, V, the speed, will be equal to square root of Young modulus over density. And that's the final answer, to have the relationship between V, the speed, the Young modulus, and density. Now, for more example, under the number 3 uses of dimension, try to subscribe for the next video.